Hello friends, recently I was reading an article on the internet about the 20 biggest solar projects in the Netherlands, and I was going through the content, and then there was a list of all the projects from the Netherlands which are big in size, such as 43 megawatts, 30 megawatts, and one project in particular caught my eye, and this was called Zonnepark Wolderspoor. So it's a solar park, and then I just quickly looked on the maps to just look at what exactly that solar park looks like, and then here it is. This is how the solar park looks like. This is such a beautiful system. When you zoom in onto the project, you'll see a lot of solar panels, and then you'll also see that there is a hill on the solar below the solar panel, and then it got me thinking, okay, this is interesting. So solar park is built on the top of small hill, and with such a beautiful blue solar panel. There is a small table of maybe 3 panels in the horizontal row by 4 panels in portrait mode, so 3 by 4 table. Likewise, then you have inter row spacing between the tables. There are a couple of ships possibly on the ground, maybe they are eating the grass, and then when you zoom out, it just looks so beautiful. And that got me thinking that, okay, what if we use a bifacial solar panels at this location? Because there is a lot of space between the rows, meaning there will be a lot of sunshine received from the back of the panels, which will increase the yield of the solar park. And then got me thinking, okay, why not do the PVC simulation of this park? Hence, in today's tutorial, I'm going to show you how to do a bifacial simulation. More importantly, I'm going to show you how to calculate the optimum tilt angle and the row spacing for a bifacial system with a batch simulation in the PVsyst software. When you open a PVsyst, the first thing you'll notice is the new design of PVsyst 8.0 version. As you can see, the layout of the PVsyst software has changed. First, you have a project design. If you have any recent projects open in the new PVsyst software, they will be displayed at this location. Then you also have a documentation tab where you can access the great resources prepared by PVsyst itself. First is the help section, which will open a window in itself, and then you can go through a lot of documentation. The second tab is the FAQ, video tutorials and PDF followed by it. And as you will see here, a lot of questions are basically comprised on this page, where you can actually go through the existing questions. If they are already answered, you know the answers of your questions. If they are not, you can also ask your latest question. Then the video tutorials will refer you to the YouTube video of the PVsyst, and then you have a great documentation of the new PVsyst displayed in the form of PDF, and basically you can go through any topic you are interested in, and then just scroll through it, and then you have a great documentation with the instructions on how to perform a selective task that you are interested in. Then you also have a utilities and your workspace. Now, because we want to do a batch simulations, we go to project, new grid connected project. A new window will be opened. Now you can choose the project name, batch simulation bifacial system. Now once you do that, the next instruction would be choose the geographical site. Now you click on the plus icon, and then the new tab will be open. Now immediately one thing you will notice on the new 8.0 software is that the map itself has changed to a satellite view rather than a terrain view in the past versions of the software. So if I go on my Google Maps, and if I just copy paste the coordinates of the location, copy and then paste it here, paste, and then do a search, you'll immediately see a really good map, and where you actually see the existing system as you see on my Google Maps. Then you accept the selected point, and then it will redirect you to a new tab, which will ask you to put a location, a site name, which I would put it as SN. The most important one is, okay, follow the instruction. Please import the monthly weather data. Now we need to import a weather data from either of the resources listed by a PVsyst software. Generally we use PVsyst TMY, typical meteorological year, version 5.2. In the past version of the PVsyst, we used to have 5.1 version, but now they have probably removed it for a certain reason, and now we are only allowed to use 5.2. Now you say import, and then you wait for a couple of seconds. Now you click on OK, you keep the name as it is, and you do the save. your graphical site has been saved in the database. You say okay, you wait for a couple of seconds, you say do you want to save the data? Yes. Keep the file name as it is, and the file has been saved. Now select the data file, please save the project. Now you go to save, you have a description and then you also have a file name. Normally I like to keep the same file name as the description, and then you say save. Now you will be asked for the first question, please choose the plane orientation. When you click on the orientation tab, a new tab will be open. Again, as you can see, the layout of this software has changed substantially. Now you can add multiple orientations, as you can see here, and then with that orientation you can probably have multiple tabs, something like this. If you want multiple orientation, you can keep it. If you don't, you can delete it from a bin icon. Yes. Now because we are going to do a simulation for the bifacial, we need to select a field type, and there is no separate option for a bifacial system, but what PVsyst recommends is using unlimited shades. So you click on it. But what does it mean by unlimited shades? We do not know. So what we can do is click on this help icon. You can also do it by pressing F1. Then there is a new documentation from PVsyst, and then here you can see unlimited shades. What it means, behind the idea is to have a full system with mutual shadings without requiring a 3D scene. So if we choose this option of unlimited shades, we do not have to define a 3D scene. Okay, so then once you have it, now you will see a couple of things on it. First is orientation. So you have to first define a field type. The name will be automatically chosen. You can define your own name, and the module area will be defined. The second thing is the orientation parameters, shade parameters, and the electrical effect that you will have to choose. Now let's say that we want to have 10 degrees tilt angle. Azimuth would be 0, meaning it will be perfectly south oriented system, and the number of shades would be, let's say, put it maximum 100. Now the pitch angle is something between the two rows of a PV system, meaning now this will be your pitch of the system. So what is the pitch? Pitch is nothing but the distance between the end of the first row and the start of the second row of the PV system. So in this case it is defined as 5.5. The collection band is nothing but a plane on which your system will receive the irradiation from the sun. So that is defined as 3 meters. Now is it okay? Is it not okay? That is dependent on those the solar panel or solar module that you are going to use in a system. Now at the moment I do not know which solar panel I am going to use. So what we are going to do for now, we skip this. We just say okay. Then we have to define a system. We go to a second tab, system. Wait for a couple of seconds. In here we have basically a similar tab where we have to define your PV system. As you can see, the list of subarrays are moved from the right side to the left side in the new PVsyst software layout. Click on the filter bifacial module, scroll down to the bottom, choose the watt peak of the panel, and then click on open. Wait for a couple of seconds to window to pop up, then go to size and technology, tab on the top, and then you will see the length of the panel is 2.2 meters. Because we want to use a module in a portrait mode with 4 modules on top of each other, we will have to define the collection bandwidth is equal to 2.2 multiplied by 4, that will be 8.8 meters. Once this is done, PVsyst is asking us to define the system. So we click on the system. We already have defined a manufacturer, a watt peak of the bifacial system. Now we need to define one more parameter, is a bifacial system. Click on the bifacial system. Now if you remember, in the orientation tab we use the unlimited shades for the 2D model, because we do not have to then define a 3D model. So when you click on 2D model, it will immediately redirect us to unlimited shades 2D model. So do that. Yes. Now here you will see that all the parameters you have defined in the orientation tab are already chosen and shown here. So we keep it for now as it is. We do not change anything. Only thing you need to check is a ground albedo. So when you click on the help button, you will be directed to a help tab about the albedo. Albedo means the coefficient is a fraction of global incident irradiation reflected by the ground in front of a tilted plane. What it means? Basically, when the sunlight comes and then is reflected from the ground, how much of the energy is reflected back from the ground to back into the sky or the solar modules. And then when you look at the documentation, there are different types of the ground material which has a different reflectivity. So in percentage, if you have urban environment, is about 15 to 22%, grass reflects about 15 to 25%, snow, as you know, the white color reflects the light, so its highest is 82%. So accordingly you will have to define which albedo you need to choose for your system. But again, in this case, the aim for our batch simulation is to understand what are the optimal parameters for your system so that you will have the highest energy yield output. So for now we keep it as it is. You press OK. Now we need to select the inverter. We will go with the most known Huawei. We'll go for 100 kilowatts inverter. Let's say 400 volts AC. Now we do not know what the kilowatt peak size, the DC or the AC size of your system would be. So I'm just going to define it as 5 megawatts, so 5000 kilowatts. And then PVsyst automatically chooses a number of modules in a series and the number of streams that you would need for this project. So once I click OK, you say there is a warning, but you say OK. Now a couple more tabs will be open for you to do more in-depth analysis and put more parameters into the simulation. The most important for us is now the detailed losses. In the detailed losses, we keep it as it is. We will choose UC as a 20, but because it's a ground mount freestanding system, we will use free mounted system. Ohmic losses we'll keep as it is. We'll keep it as a default. Use AC circuit losses. Let's say we will choose 1% AC loss. We will keep 1.5% DC loss for now. We keep all the parameters to be default. If you have the actual parameters from your pan file of the modules, you can choose the numbers according to your analysis. The soiling loss, I will keep it as 3% as a default. IM losses, we do not change anything. Unavailability losses, I will keep 2%. In a whole year, the system will be down. Once you define the losses, you say OK. Now the most important part becomes is we choose the advanced simulation. In the advanced simulation, this is where exciting part starts. In the advanced simulation, you will click on the batch simulation. Now in the batch simulation, a new tab will be open. Now here we will define a batch CSV file, simulation parameters and the results variable specification. All of your files will be saved at a drive, then user, your name, PVsyst 8.0 data and subfolders, in this case for user batch. If you have a different decimal system on your Windows operator, you can choose Windows settings, semicolon, comma, tab according to your liking for a CSV file. I will keep it as a Windows settings. Now once you select all these parameters, you go to a second tab, simulation parameters. In this tab, you have to choose 4 different tabs for defining your system. Now first one is a weather data and a site specification. I just want to select one weather file for this system because it's located at a specific location. I do not want to create a new weather file or multiple weather file for the simulation. So I will not change anything here. Now in the saving mode, you have different options. Do you want to produce multiple calculations versions, or do you want multiple files, whether you want to create a PDF report after you have done the analysis. Then you choose the plain orientation. Now if you remember what we discussed earlier, is we want to check with the batch simulation what are the optimal parameters for our bifacial system. Now which are those parameters we want to check our bifacial system for? We will not change the number of shades, but we want to keep changing the plane tilt, the orientation of your system, azimuth, and then we also want to check the pitch between the rows. We have defined as a 10 meters, but maybe if you keep the distance between the rows higher, let's say 15 meters or 20 meters, you may get a lot more irradiation on the backside, which will increase your energy output. I also want to check if I increase the height of your PV system from the ground, will it increase the energy output or not. Also, as we discussed, there is very important point is a ground albedo. Once we have defined the number of variables we want to do the permutation and the combination checks, we go to a next parameter is a system parameters. I will not change anything here. Or maybe we can also try a number of modules in a series, but for the sake I will keep it simple. I will not change anything, and the losses we already have defined it. I will keep it as it is. Now Once the losses are defined, we go to the next section, results variable specification. So at the end of the simulation, what do we want to see? We want to see the energy output of your bifacial system. So that is located in a grid system under system parameter. So what exactly we are doing? We are defining which are the variables we want to see at the end of the simulation, that is the energy injected into the grid, or that is the energy simulation of your bifacial system. Now, once you have defined all the parameters in batch CSV file, simulation parameters and results variable specification, you click OK. Then the new pop-up window will show you where the new Excel sheet is defined, where you will have to define a different simulations. So I'm going to open the Excel sheet. When you open the Excel sheet, which is located at the defined path location in the pop-up window, you will see a couple of instructions. First, Excel sheet will show you the information about the file, project and the variant. The most important instructions from the Excel sheet are, we need to define a parameter for each simulation run. We cannot modify the names of the columns, and the most importantly, all the simulation that starts with capital SIM underscore will be executed. So if you miss, for example, a column where you have similar parameters like this, but there is no identity of a simulation run, PVsyst will not run a simulation. So you will have to define something like this. Now, before we define all the simulations, what we need to define what we want to change. So we will be changing tilt angle. We will not change the azimuth angle. We will change the pitch of the system, height of the system from the ground, and the albedo. So we will change the tilt of the system from 10 degrees to 90 degrees in steps of 10. We will not change the azimuth. We will keep the system to be perfectly south oriented. The pitch of the system will change from 10 to 12 meters, in steps of 1 meter. The height of the system from the ground will change from 0.5 meters to 2 meters in the steps of 0.5 meters. And the albedo we will keep to be 20 for grass and 30 for concrete. Now, with this in mind, let's define a system. For example, we'll do 20, 30, and so on. Azimuth to be 0, we'll keep the shade angle to be 10, height to be 0.5 as start, and then the albedo to be 20. Now when this is done, we can define the pitch shade to be 11, then we'll define it to be 12. Once this is done, we need to also put a simulation identity, so it goes to 2. Similarly, then we just drag and drop to 27. Now I will define the system for you and get back to you in a minute. Once the simulation is complete, PVsyst will show a pop-up window saying the batch simulation is completed, and the execution file, the results are located at a location with a file name batch simulation bifacial system results underscore 0.csv. Once you open a CSV file, you will see its values separated by a delimited semicolon. So to convert a CSV file into a readable Excel sheet, you go to data tab, text to columns, select column A, data text to columns, delimited by semicolon, and then you say finish. What you see here basically is a simulation parameter, variant identity, the tilt angle, azimuth, shade, and important is there are no errors on the simulations. So, and then finally you have energy injected into the grid. Now we are going to do some basic analysis of the data. So what I do not need, so I'm going to copy paste all the data, click on the new sheet, paste it here. We do not need a couple of rows, so I'll perform some data analysis, basic data analysis on the file. Once your analysis is complete, now you can go back to the main parameters, orientation, if you want to change any orientation. Based on your analysis, if you have defined which plane tilt, azimuth, the shades, the pitch you want, you can define the parameters here. And then you can go to systems, and then you can define your own system based on the analysis that you have performed. And then finally, you can run the simulation by defining all the parameters, optional parameters, and then by clicking run. And that's it.